Good evening everyone. Welcome to my class. Today I am going to teach one of the important topic, oscillation and waves. In that one, let us discuss in detail periodic and simple harmonic motion. Oscillation and waves, this is the theory class. After this class, I will solve few important MCQ questions in the next class. That's why this theory class is very important. If you know this one, then easily you can solve the multiple choice question. Okay, let us start the class. Today topic is periodic and simple harmonic motion. Yes, let us study what is meant by introduction to periodic motion. Wait a minute, I am checking whether it is going live or not. Yes, it is correct now. Okay, introduction to periodic motion. The name itself, it is indicating periodic means the motion, it will be repeated at an equal intervals of time. Introduction to periodic motion. We can classify the motion of various bodies on the basis of way they move. For example, a car is moving on a straight road is said to have a linear motion. Yes, if a car is moving on a road in a straight line, that one we will consider as a linear motion. Linear, it will represent a straight line. If a car is moving on the road in the straight line, this motion we will consider as a linear. Linear means always in your mind you have to remember the object is moving in a straight line. Similarly, the motion of the earth around the sun is the circular motion. Already you know, the earth, it will be revolving around the sun in the circular motion. Therefore, this is also an example of a circular motion. In this session, we shall be discussing periodic motion along with its formula. Yes, in this class, in detail, we will study about the periodic motion. Normally, here I discuss two types of motion. One is linear motion, circular motion. Linear motion means if an object is moves in a straight line, that motion we will consider as a linear motion. If the object is moving in a circular path, that motion we will consider as a circular motion. These are the two difference between the linear motion and also circular motion. Then let us study in detail about the periodic motion. A motion that repeat itself after an equal intervals of time is known as a periodic motion. Periodic, the name itself, it will indicating the motion that it will be continuously repeat itself at an equal intervals of time. At regular intervals of time, if the motion repeats, okay, that type of motion we will consider as a periodic motion. Let us consider here periodic motion when a moving object passes through a certain point of regular interval of time is known as its periodic motion. Okay, the motion of a hands of clock, here you can see even minute hand is there, second hand is there, hour hand is there. All these three, they will be moving in the circular path, and also at equal intervals of time they will be continuously, they will be changing periodically, they will be changing. You can see the movement between the minute hand, hour hand and second hand. At equal intervals of time, the position of all the three hands, they will be continuously changing. Therefore, this is also motion of hands of a clock. Okay, this is also very important example of a periodic motion. Next one, motion of earth around the sun. Not only earth, motion of another planets around the sun, that is also an example of a example of a periodic motion. These two motion, they will be in the circular path. These two are the example of even circular and also periodic motion. Okay, Once if the object is moving in the circular path, that is an example of a circular motion, but here the object is covering equal distance at equal intervals of time, therefore this is also one of the example of a periodic motion. Okay, always in your mind you have to remember periodic motion means the object covers equal distance in equal intervals of time. That one you have to remember. Whether it is a circular, linear, that it will not matter, but it will travel, otherwise it will cover, otherwise the motion it will get repeated at an equal intervals of time. That one is very important. That one you have to remember. Which one is easy? I will go fast. Which one is difficult? This chapter is easy. Periodic and simple harmonic motion is the easy one. Okay. Next, coming to the next example of periodic motion, a tuning fork or motion of a pendulum. Even the tuning fork you can study this one in the second PUC. We did the experiment also. Tuning fork, when you hit the tuning fork to any hard object, then it will start vibrating. How it will vibrate? Periodically it will be vibrate. This is also one of the best example of a periodic motion. Okay. Then motion of a pendulum. Here consider this is an pendulum. Here when you disturb the pendulum it will start oscillating. That oscillation it will be periodic. Okay. If you analyze the motion, you will find that pendulum passes through the mean position only after a definite intervals of time. This is the mean position. These are the extreme position. The AB we will consider as a extreme position. This is the mean position. Okay. In pendulum, this one I will explain in detail. Okay. A, B are the extreme position. At the point O, this is the mean position. Here the pendulum it will oscillate at the extreme to the mean position with periodic motion. Okay. That one only they are telling here. You will find that the pendulum passes through the mean position only after a definite intervals of time. This is the mean position, this is the extreme position. Only at a definite interval of time, this pendulum it will reach the mean position. We can also classify the above motion to be oscillatory. Even we can consider this one as a oscillatory motion. Even periodic motion also we will consider. Why it is a oscillatory motion means the pendulum it will start oscillating like this periodically. Okay. Next one, an oscillatory is a motion in which the body moves to and fro about a fixed position. Here you can observe this bob. Okay, this pendulum it will get oscillated to and fro motion about a fixed point. Here you can observe this the fixed position at one rigid object, otherwise at one point this pendulum is get fixed. Then this is the wire you consider, or this is a thread you consider. Then this is the bob, iron bob. Then when you suspend this one freely in the air, then it will start oscillating. Okay, this is the to and fro. How the pendulum, how it will get oscillated? It will get oscillated in to and fro position. Okay, then so an oscillatory motion can be periodic. It is not necessary. Sometime what will happen? Sometime the oscillation of a pendulum, sometime it will be periodic, but after some time it will loses its periodicity. Why it will loses its periodicity means once the pendulum once it will start vibrating, then it has more energy. When it is having more energy, then periodically it will oscillate. Once this pendulum once it will start losing the energy, when it will start losing the energy, assume you are not providing any external energy. This I will explain in detail. Forced oscillation, damped oscillation, undamped oscillation. In that case in detail I will explain. Okay, once this pendulum once it will start losing energy. Okay, once it will start losing energy, then this periodicity it will be lost, because continuously it will start losing energy. That energy is not sufficient to make the bob to oscillate periodically because of the low energy. Otherwise, because of start losing energy, because of the decreased energy, this pendulum it will lose its periodicity. But at the beginning, the pendulum it will be oscillate periodically. This one we will explain, I will explain in detail. Okay, understood everyone here? You can ask me, ma'am, you told in the beginning uh, oscillation of a symbol pendulum is a periodic, but now you are telling it is not periodic after some intervals of time. Because at the beginning, when you touch this one, when you start oscillating this bob, it is having more energy. When it is having more energy, then the oscillation it will be periodic. But after some time, what will happen? The energy it will started losing. Okay, energy it will started decreasing. Because of the decreasing energy, this bob it will not possess that much of energy to keep the pendulum oscillate periodically. That is the important reason you have to remember. Okay, yes, I will move to the next one now. Very important one. Okay, next, periodic motion formula. This topic is very easy, you have to understand. Okay, periodic motion formula. What is the terms you have to remember here? Time period, frequency. It is the time taken by the motion to repeat itself. So the unit of time period is second. What is mean by time period? Okay, if a motion, the time taken by the motion to repeat itself. Already I told periodic motion is a motion that repeat itself at an equal intervals of time. I told. To repeat the motion, how much time it need, whether it is a 10 second, 20 second or 30 second. Maybe assume at one particular motion, every 10 second it will get repeated. Okay, then time period of that motion it will be 10 second. Okay, understood now? Time period is nothing but it is the time taken by the motion to repeat itself. So the unit of a time period is second. Understood? Second one, frequency. It is defined as the number of times the motion is repeated in 1 second. In 1 second, how many times the number of times, otherwise how many times the motion it will get repeated. That is nothing but frequency. Number of oscillation per second also you can consider. The unit of frequency is hertz. Simple words. Frequency is nothing but number of oscillation per second. Okay, because we will consider in the simple pendulum, for 1 second how many times it will get oscillated. Okay, that is nothing but a frequency. Frequency is related to time period as f it will be equal to 1 by t. F it will be equal to 1 by t. This is the relation between frequency and time period. Units you have to remember. SI unit of time period is second. SI unit of frequency is hertz. That one you have to remember. Understood now? Very easy. Okay. Next, what is mean by a amplitude? Consider this is a wave. This is the time period to repeat one oscillation, to repeat one wave. Here, this is the one wave, no? This is the one wave, crest trough. This is the one wave. This one, how much time it will take to oscillate, otherwise it will cover one wave. That is nothing but a time period. Then the next one, the amplitude of a wave refer to the maximum amount of displacement of a particle on the medium from its rest position. Otherwise, simple words, amplitude is nothing but height of the wave. This is the amplitude you can consider here. This is the amplitude. Amplitude of a wave is referred to as the maximum amount of displacement. Yes, you can observe this is the displacement of a particle maximum amount of displacement. Displacement of a particle on the medium from its rest position. This is the mean position. This is the rest position, otherwise mean position you can consider. How much maximum displacement of a particle in the medium, that we will consider as a amplitude. Otherwise simple words, height of a wave is nothing but the amplitude. These terms are very important. That's why I'm explaining in detail. When you are solving the problem also it will be important. Now already I told simple pendulum, otherwise oscillation of a pendulum. Sometime it will be periodic, sometime it will be non-periodic. Okay. Then that is also one of the example of a simple harmonic motion. Let us study in detail what is meant by simple harmonic motion. A simple harmonic motion is a periodic motion. This is also one of the type of the periodic motion. The body moves to and fro from its mean position. Yes, here you can observe here. This is the simple pendulum. This is the support, otherwise fixed point. This is the string. This is the bob. This is the equilibrium point. Sometime we will consider as a mean point also. This is the maximum point. Even we will consider the word extreme. Extreme also same. Maximum point, extreme point we will consider. Both the words are same. Simple harmonic motion is also one of the type of periodic motion. Okay. Simple harmonic motion is a periodic motion. This is also one of the type of the periodic motion. The body moves to and fro about its mean position. Here the body it will move to and fro from its mean position. Okay. Those who are there in the live, you can comment me hi, then I can interact with you. Tell me hi, those who are there in the live. Okay, next one, it is defined as magnitude of maximum displacement of the particle from its mean position. Here, this pendulum, when it will start oscillating, it will reach the maximum point. Then it will come back to the mean position. Again it will move to the another maximum point. Again it will come back to the mean position, otherwise equilibrium point. Simple harmonic motion is a periodic motion. The body moves to and fro about its mean position. That is the proper definition of a simple harmonic motion. It is defined as magnitude of maximum displacement of the particle from its mean position. Magnitude is nothing but the number, how much the bob, how much, otherwise magnitude is nothing but a number. Okay, the magnitude of maximum displacement of the particle. This particle, assume this is the bob, up to the maximum level it will oscillate. Again it will come back to the mean position. Other side also it will move to the extreme. Again it will come back to the equilibrium position. Tell me those who are there in the live. Tell me hi, then I will come to know. Next one, simple harmonic motion or SHM. What is simple harmonic motion? Simple harmonic motion or SHM is defined as the motion in which the restoring force is directly proportional to the displacement of the body from its mean position. See, another definition of simple harmonic motion is defined as restoring force, okay, is directly proportional to the displacement of the body from its mean position. Then what is meant by a restoring force? The restoring force is a force which acts to bring a body to equilibrium position. Already I told this is the equilibrium position, otherwise mean position. When you touch this bob, it will move to the extreme position. Okay, this is the displacement. This distance we can consider as a displacement. Okay, this one we will consider as a displacement. Restoring force is a force which acts to bring a body to its equilibrium position. Once the pendulum once it will reach the extreme position or maximum point, it has to come back to its equilibrium point or mean point. It has to come back to its equilibrium point. Then to achieve this one, the force is needed, no? That force we will consider as a restoring force. Once again I will explain, listen here. This is the equilibrium position of a bob. The bob, it will move to the extreme point when you touch the bob. Then it will achieve some displacement. You can see the displacement here. Then restoring force is nothing but the force required to this bob, otherwise the force required to bring this bob to its mean position. How much force is required? That force is nothing but restoring force. Here what they are telling, this force is directly proportional to the displacement of the bob. If the displacement is more, the force is more. If the displacement is less, the force is less, obviously. Okay, this is the formula, otherwise this is the relation they are telling here, in which the restoring force is directly proportional to the displacement of the body from its mean position. The direction of this restoring force is always toward the mean position. This is the direction of the restoring force. Yes, because once this bob, once it will move to the maximum point, it has to come back to its mean point. To come back to its mean point, it requires some force. That force is nothing but a restoring force. Therefore, the relation you have to remember here, this restoring force is directly proportional to the displacement of the bob. How much it will get displaced. Force is more when displacement is more, because to bring the bob to its mean position, if the displacement is more, you need more force. If the displacement is less, you need less force. Okay. Yes. Okay. Next one, the acceleration of a particle executing simple harmonic motion is given by this formula. Here omega is the angular velocity of the particle. That one you have to remember. Omega is nothing but angular velocity. Okay, let us discuss few more example of a simple harmonic motion, SHM. Swings that we see in the park is an example of simple harmonic motion. Best example. Normally, daily life we will see this one. Swings that we see in the park is best example of simple harmonic motion. Here, these two kids, they are swinging. Okay, the back and forth repetitive movement of the swing against the restoring force is the simple harmonic motion. See, restoring force, this boy already from mean position he went back. Okay, that boy, he has to come back to its mean position or original position. Then he needs some force, no? That force is nothing but a restoring force. Therefore, swing is the one of the best example of a simple harmonic motion. Next, bungee jumping. This one you can observe. Bungee jumping is an example of a simple harmonic motion. The jumper oscillating up and down. Here the oscillation, it will be up and down. Whether it is up and down, whether it is to and fro, these are the example of a simple harmonic motion. Due to elasticity of the bungee cord. Yes, you can observe in the bungee jumping, the jumper, he will get oscillated in up and down. This also one of the example of a simple harmonic motion. The elasticity of the bungee cord, how he can jump up and down, because of the elasticity of the bungee cord. Next, cradle. This one also you can observe in your home, those who are having the small baby. The back and forth, here the back and forth movement of the cradle is caused due to the single push is maintained by the simple harmonic motion. When you touch the cradle also, you can observe it will get oscillated back and forth. Okay, hence causing the baby to sleep. Easily that baby they can sleep. Next one, hearing. This is also one of the best example of simple harmonic motion. Let us discuss hearing. The process of hearing is impossible without simple harmonic motion. The sound waves that enter our ear cause the eardrum to vibrate back and forth. Hearing. See here, once the sound waves they will be oscillating like this. They will be in the form of a wave. Once this sound waves, once they will reach the eardrum. Here you can see the eardrum. Eardrum, it will start vibrating. This is also an example of a simple harmonic. Here is the eardrum. Here you can see the eardrum here. This is the sound waves. How we will hear the sound? When sound waves, they will reach our eardrum. The eardrum, it will start oscillating. Okay, that signals it will move through the brain. Then we can easily recognize the sound. Which sound? What is the meaning of the sound? Everything it will be recognized by our brain. The oscillation of the eardrum also one of the example of simple harmonic motion. Let us discuss the difference between periodic oscillation and simple harmonic motion. Let us discuss the difference between periodic oscillation and simple harmonic motion. Periodic motion, a motion repeats itself after an equal intervals of time. For example, uniform circular motion. Already I explained in detail. Periodic motion means the motion it will be repeated at equal intervals of time. Best example are linear motion, uniform circular motion. Here there is no equilibrium position. Yes, in the periodic motion there is no equilibrium position. There is no restoring force. These are the point, very important point in the periodic motion. There is no equilibrium position. There is no restoring force. There is no stable equilibrium position. Next one, oscillatory motion. Next one, oscillation motion. To and fro motion of a particle about a mean position is called as an oscillatory. Yes, the name itself is indicating in oscillatory motion, the body it will get oscillated in to and fro motion in which a particle moves either side of equilibrium mean position is an oscillatory motion. Here in the case of a periodic motion, there is no equilibrium point, there is no restoring force, there is no stable equilibrium position. But in the case of an oscillatory motion, you can observe even the mean point is there. The object it will get oscillated in to and fro motion, and here you can observe the equilibrium point on both the side, mean position, everything you can observe. Simple harmonic motion, that pendulum experiment, that one you have to remember. Next one, it is a kind of periodic motion bonded between two extreme points. Yes, in the oscillatory motion, already I told how many extreme points are there. Two extreme points are there. For example, oscillation of a simple pendulum, in detail I explained. Then spring mass system. Here you can observe two extreme points are there. Okay. Next difference, the object will keep on moving between two extreme points about a fixed point is known as a mean position. Yes, if you consider this the fixed point, I will rub this one. Wait, I will. Okay, this is the fixed one. Then this is the bob. It will move to the two extreme points. These are the extreme points. Here this is the extreme. This one is the extreme. This is the mean position of the bob. Then two object will keep on moving between the two extreme points about a fixed point is called as a mean position. This one we will call it as a mean position or equilibrium position along any path. The path is not constant. Yes, here this is the mean path, otherwise mean position, equilibrium position, everything it will be same. According to the fixed object, they are telling fixed point. There will be a restoring force directed towards equilibrium position or mean position. Already I told the restoring force, it will be towards the mean. Towards the mean, the restoring force. Once this bob, it will get displaced to a extreme position, it has to come back to its original mean position. It needs some force. Without force, it will not come back. That force we will call it as a restoring force. Therefore, this restoring force in both the side, always it will directed towards the mean. In an oscillatory motion, the net force on the particle is 0 at the mean position. At the mean position, the net force, okay. In an oscillatory motion, the net force on the particle is 0 at the mean position. At the mean position, net force it will be 0. The mean position is a stable equilibrium position. This one is the stable. This position we will consider as a stable equilibrium position. Very important thing we learned based on this oscillatory motion. Next, simple harmonic motion. I am explaining the difference between the oscillatory motion, then simple harmonic motion, periodic motion, everything. It is a special case of oscillating along with straight line between the two extreme points. A path of simple harmonic motion is constant. Path of the object need to be a straight line. Yes, here the path of the object, always it will be a straight line. There will be a restoring force. Here also you can observe the restoring force directed towards the equilibrium position, mean position. The simple harmonic motion, oscillatory motion, almost they will be same. Mean position in simple harmonic motion is stable equilibrium. Yes, everything it will be same, but what you have to remember, only in the case of a periodic motion, there is no equilibrium position, there is no restoring force, there is no stable equilibrium position. That one you have to remember. Okay. Next, definition of oscillation. What is mean by oscillation then? Oscillation is the regular variation in the position or magnitude about a central point about a mean position. The commonly used unit for the number of oscillation per second is hertz. About a central point, mean point, everything it will be same. Which one is easy for you? Remember that one. Oscillation in physics are quantified using the parameters such as frequency, amplitude, period. What is mean by frequency? Time period, amplitude. How much is there? I will see. Otherwise, I will consider this one as one more class, because this it will become lengthy. Means okay, I will do types of oscillation. I will do it in the next class. Then up to here, I will explain. Okay. period of oscillation, the time taken for one complete oscillation is called as a time period. Its unit is second. Its symbol is time. Period of oscillation. Time period of an oscillation. To complete one oscillation, how much time it will require. Oscillation frequency. The number of oscillation cycles per second we will consider as a oscillation. Frequency, its unit is hertz, then the symbol is small f. That one you have to remember. Next one, oscillation amplitude. Oscillation amplitude, the maximum displacement from the mean position is called as the amplitude of oscillation. Maximum displacement, when you consider the wave like this maximum displacement of the wave, this one we will consider as a amplitude. Its SI unit is meter, then symbol is capital A. The maximum displacement from the mean position, this is the mean position. Maximum displacement from the mean position is called as the amplitude of oscillation. Easy one. Again, you have to remember the formula. T, it will be equal to 2 pi square root of capital L divided by G. Then T is the time period of oscillation. Then L is the length of the string. Then G is the acceleration due to gravity. Very important formula. Based on this formula, I will solve important MCQ questions. Next one, oscillation frequency. Formula F, it will be 1 by T. T is the time period of oscillation. Then next one, example of oscillations. Do you know that the vibration of a guitar string is an example of an oscillation? Yes, guitar, you can observe. In guitar, strings are there. When they touch the strings, it will make a sound. The motion of a playground swing, tuning fork is also an example of a oscillatory motion. Best examples are in the playground, you can see the swing, also example of oscillatory motion. Then tuning fork, since these are mathematical in nature, they are also called vibration. The motion of alternating current is also an example of an oscillatory motion. In the next class, I will explain different types of oscillation. This one is very, very important. Damped oscillation, forced oscillation, free oscillation, everything I will explain in the next class, because this it will become lengthy, almost 40 minutes over, no? That's why. Please, those who are not there in the live, please see the recorded class. Please watch the recorded class. If you have any doubt, anything, you can ask me, you can mail me. Please watch my videos, share to your friends, those who are preparing for hstr, then gpstr, then tet, ctet, everything. Those who are preparing for competitive exam, science and maths, please share my videos, subscribe, then watch whenever you are having the free time, watch my video. Okay, thanks for listening my class. Thank you everyone. Take care. Bye. Read.